is basically just graphing inequalities that have the same structure as a linear equation. All right. So if you look at the top examples with the little blurbs there, you see the graph of a line, y equals x plus 4, just ordinary y equals x plus 4. Very simple. You type in the equation into your calculator, you get a y-intercept if you need it. All right, that corresponds to what you see on the graph. Everything is pretty straightforward. The solutions for this graph, the graph is the solution. All right, so anything that falls on this line would be considered something that satisfies this equation. All right, so what we're looking for is now something that would satisfy this inequality. All right, so values of x can vary, but if you add 4 to it, whatever that result is needs to always be bigger than whatever the y value, the corresponding y value is. That's kind of hard to conceptualize, but graphically, what that means is that you graph the line. Oops, that's a little thick. Graph y equals x plus 4. So the line y equals x plus 4 as a dashed line. All right. And it's dashed because it involves a less than symbol. All right. So if it were a less than or a greater than symbol, you use a dashed line. This corresponds to the same idea as like an open circle when you plot it on an ordinary number line. All right. So the dashed line kind of fulfills that same responsibility. It's better. Well, I mean, in theory, this would be equivalent to if I put like little open circles along that linear path, which is really cumbersome. So they said, let's just make a dashed line. All right, that's really all there is to it. So dashed line would also apply for a greater than symbol. All right. But then we'd have to shade in one direction or the other depending on the nature of the inequality. So if it's a less than, shade below. If it's a greater than, shade above. There are exceptions to that idea. That the exceptions only involve the vertical case, which I'll show you in a minute. But that's a pretty standard rule because you look at the dashed line here, you have two regions. That dashed line separates the graph into two components, the part that's above it and the part that's below it. All right. Now it's not directly above it, like a horizontal. You have a clearly defined above and below. All right. But even with a diagonal line, there's a part where you look at it and say, well, that part's the part that's above. All right. Now, the only part that would be a little confusing would be over here, where you'd say, well, is this above anything? Well, you'd have to imagine that this line could extend on forever. That shaded region is never going to be above anything. All right. So if you're ever in doubt, that's where Desmos comes into play. And it's a beautiful thing. And even the TI calculator will do it. It is just a couple extra steps, but it'll still do the job for you. One sec. All you'd have to do is type in the inequality exactly the way you see it. It'll shade it and dash it appropriately, which is really nice. All right, and it's something that, in years past, before Desmos even existed, this is something that it's like, well, you make your dash line, you plot everything correctly, and you're like, okay, I don't understand how to shade. I'm just going to guess. All right, it's one or the other. I'll take a shot in the dark here. All right, but now you have the ability to just have the answer, the correct answer, and then just worry about why it works the way it does later on. So what I do is I just test a value in my mind for X and Y from the shaded region and the not shaded region, and just make sure that it plays out. Question?
Well, less than or greater than sign basically means that anything in the shaded could be the answer. It doesn't have to be on the line necessarily. It's anything in the shaded.
Correct. And in fact, with a dashed line, your solution will not actually be on the line.
Oh.
Right? It would have to be a solid line in order for that to be the case. But like, for example here, I mean, a very simple value, 0, 0, that falls in the shaded region. All right, you see that point definitely falls in the shaded region. You can test that in your original inequality and make sure that it gives you a true sentence. I mean, it's a while ago, but we talked about the idea of truth values, the ands and the ors and all that stuff, but deciding whether a sentence was true or not. All you would do is put a 0 in for x and a 0 in for y and make sure it gave you a true sentence. All right. So if I replace in this inequality, so I would test just any value I want from what I think the shaded region is, test 0, 0. I like 0, 0. It's in the shaded region, and you know what? It's a nice coordinate. Why not use it? So test that in my inequality, replacing the x value with 0, the y value with 0. So 0 less than 0 plus 4, 0 is less than 4. That's true. So that means wherever you decide to make your shading, 0, 0 should be in it. 0, 0 should be in that shaded region. All right. That's if you want to, actually verify it manually. All right. Sometimes the question on the regions will ask you to do that. Verify that this point is part of the solution, and they'll give you the point. So you'll have to use the point that they decide upon. But like something like number 1 on the bottom or in the next section, I can look at that the same way and say, all right, well, here's the point, 0, 0. Is that in my solution? So I test 0, 0 in my inequality. 0 greater than 5 times 0 plus 7. Is 0 greater than 7? That's a false sentence. 0 is not greater than 7, which means 0, 0 should not be in my solution area. All right, so that tells me that my solution area should be everywhere on the graph that does not include the 0, 0. All right, so I'd shade the other way. If I have my two choices are to shade to the left of that diagonal line or diagonal dashed line, whatever, or shade to the right, and 0, 0 I know shouldn't be in my shaded area, then logic dictates that the shading has to be the other way. But again, if you're not sure, y greater than 5x plus 7, and Desmos will shade appropriately for you. It ends up being a matter of just time. Right? You do it on Desmos, it's going to take a little bit more time because you got to type it in. You got to bring up Desmos, you got to type it in. So if you could crank it out quickly, just a quick site analysis. Like I'd look at this and say, all right, anywhere I plug in a 0, that part of it's going to go away. So if I'm testing 0, 0, I wouldn't even write anything down. This is all happening in my mind. Test 0, 0. I'd replace the y with a 0. This part would 0 away because negative 2 times 0 is 0. I would get 0 less than negative 9. 0 is not less than negative 9. That's a false sentence. All right, so wherever 0, 0 is, that should not be part of my solution. That's part of the problem. Little dad joke there for you. All right, so again, if you're not sure, type it in. Negative 2x minus 9. Okay, so I screwed that up. What did I screw up? The sign. Oh, thank you. Oh, on Desmos, yeah. It's like, I screwed up the sign on the algebra. Well, if I'm going to screw up anything, the part where I type stuff in is probably better bet than the part where I do simple math, I guess. All right. The verticals are actually a whole lot easier because the direction, so verticals the form of x equals, x greater than, x less than. The direction of the inequality is the direction of the shading. Assuming it's in this form, if the arrow's pointing to the right, you shade to the right. That actually could not be any easier. maybe don't do that. All right, again, you're not sure, type it in, x greater than 3, and there you go. And then the only real extension of this is, all right, you're given an inequality that's not solved for y. So we want to solve for y. All right, so, and this is the last one we're going to do together. Then I'll let you loose to do what you need to do. So subtract the 2x. Y less than or equal to, you have a choice of writing 4 minus 2x or negative 2x plus 4. It really doesn't matter as long as you're correct with your signage, positives in appropriate places, negatives in inappropriate places. The benefit of writing negative 2x plus 4 is that when you're creating a graph, and so I'll write that, negative 2x plus 4, you have a slope and you have a y-intercept. So if you need to produce a graph on paper, having it in this form is pretty convenient. All right, so I'd plot the positive 4, 1, 2, 3, 4, a slope of 2. Slope of 2 is the same as saying negative 2 over 1. That's a rise of negative 2 and a run of 1. So that means down 2, right 1. So down 2, right 1, down 2, right 1, and so on. It could also mean 2 over negative 1, which would be up 2, left 1. Up 2, left 1, up 2, left 1, and so on. But all you really need to draw a line are 2 points and a ruler. That's my ruler. Now this one gets a solid line. And that's the thing, like when you make the graph of an inequality, you just got to be careful, because I do this all the time, but I have digital links, so I correct myself almost immediately. But if you do it and you do it in pen and that pen's not erasable, and you realize after the fact that it was supposed to be a dashed line, after you made a nice solid line in unerasable ink, you're like, ah, crap. Undo, 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 undo. You know, it's, nah. Do it over, right? So you just gotta be careful, all right?
Do you shade with the solid line?
You do shade with the solid line, so that's what's next. We take a look at the inequality. We have that bad boy right there, which is telling us to shade below this solid line, all right? So if you're not sure what that means in this context, if you're looking at it, well, this, you have two choices. You have this region or this region. One of them's above and the other's below. If you have trouble discerning which one is which, then use a test value. All right? As long as 0, 0 doesn't fall on the line, it's a good test value. So I would test 0, 0 into, well, I could use the original inequality. I could use my simplified one. You're better off probably using the original, just because it's before you made any mistakes, most likely, unless you rewrite the inequality incorrectly. Replace the x with a 0, replace the y with a 0. You get 0 less than or equal to 4, which is a true sentence, which means we're shading in the direction. Wherever 0, 0 is, that's the side we're shading. All right. So I'm going to get some nice shading going on here. But the shading should be the least of your worries. I mean, there's a lot of stuff that we'll have to worry about more when we get closer to the Regents exam. All right, this is probably one of them, because if I just type in my original inequality without simplifying in any way, Desmos will still graph it correctly. All right, it's just picking a different color. I mean, it's not very flamboyant color, but you know, it is what it is. What can you do? But you don't even have to do any work to get the graph of these solutions. All right, which is why we're kind of breezing at the last two units, unit 2 and unit 3. We're kind of breezing through them, just because it's so unnecessary to do a whole lot of the stuff that you see in the packets. because it's already handled for us. All right, and as we get closer to the regions, we'll have to review it all anyway. So, why spend too much time on it now? We can actually dive deep into the applications of it, which is what we're doing. All right. So, anyway, that's all I wanted you to worry about today in terms of new material. Tomorrow, we'll do a little bit more, not too much. There's actually only one other topic in this unit that we need to touch on, and that would be systems of inequalities, which are, you guessed it, graphing two inequalities at the same time on the same set of axes. So what we just did here, you do it twice. All right, so that's not going to be overly challenging either. All right, so I'm going to stop the record.